So today I'm just going to talk a little bit about the role that big data can play in teaching about climate change, and Global Forest Watch as a big data tool that can facilitate that. And I thought to get started, I would start out with a very simple reminder that I think sometimes gets downplayed when we talk about climate change. And that simple reminder, all life depends on plants. Plants and climate are intimately connected. Plants are the basis of almost every ecosystem here on Earth. Fossil fuels, on which the entire global economy depends, are nothing more than really old plants and animal biomass buried in sediment. Plants convert carbon dioxide from the atmosphere into other forms of organic carbon that all of life depends on. So if we look at this figure, this is a classic environmental science class figure of the global carbon cycle, where we can see exchanges of carbon between the land, the atmosphere, and the oceans. And when we teach about ways to mitigate climate change, we often focus over here on the left portion. The left portion over here. Humans can reduce emissions by reducing our reliance on fossil fuels. We can look for ways to improve energy efficiency. But humans also have a really big influence on this component over here on the right, because the way we manage lands worldwide has the potential to both reduce sources from and enhance sinks by the world's land base. So before I go any further with my presentation, I just want to show you a short video that demonstrates how the same information I just explained in this slide, talking about the role of forests and land use in the global carbon cycle, can be presented in a much more powerful and dynamic way with the visualization of big data. We'll show that later.
We tested it.
We tested it, and it was working. So, the point of that slide was to show that a video of the Earth's concentrations of carbon dioxide and the role that forests play in reducing, during the summer months when plants are actively photosynthesizing. During the summer months, those concentrations of carbon dioxide that are really red and purple in that diagram, as the year progresses, the reds and purples become more like yellows and greens and blues because of the role that forests are playing in absorbing a lot of the carbon dioxide that we're emitting. And so the point of this video was to just kind of talk about your students, who are probably more interested in what Sarah just texted Jamie and what they're going to do on their Friday night, much more than they're interested in how many billions of tons of CO2 are absorbed by forests. We can give them these interactive tools. If we can give them moving pictures, we can give them a chance to see what happens when they press a button or move a little slidey scale around. They're going to be much more likely to look up from their phones and actually pay attention to what you're doing, right? And after your class, they'll go back to whatever they were doing on Twitter, but maybe they'll actually tweet about some cool thing that you showed them. And that would be kind of a successful teaching outcome. So the same situation that I was supposed to just have presented about the difference between the static and dynamic information, presentation of information, also applies to forest information. So many times the forest data that we rely on comes from static sources of information, such as those presented here. And it takes us a while to compile all of this information into these publications, so by the time they come out, they're already years out of date. And so the information we need is also scattered across a lot of different data sources that might or might not be comparable. They might be kind of expensive or difficult to access. They They might be too technical or complicated for an average person making decisions to understand. They also might be presented in ways that it's just really difficult to interact with the data or with other people around the data. And that just makes the work of all of us harder. And so, you know, I might know how many hectares of forest a country has, but I have no idea where those forests are. I have no idea which forests are under threat versus not, which ones are contributing most to climate change when they're cleared. So even when global maps are produced, they're generally produced at very coarse resolution that are of little value to local decision makers. So just contrast that with the world of business and finance, where anybody from the CEO of a Fortune 500 company to an individual managing their own bank account has access to information across thousands of companies, across many countries, all in near real time, updated almost every second. And all of that information is also completely free, right? And despite the complexities of the underlying data, it's presented in ways that are easy to understand and make decisions. So that's the idea behind an initiative at WRI called Global Forest Watch, which is a new online dynamic forest monitoring platform that we launched just about a year ago. And at Global Forest Watch, we believe that data, and in particular open data, is a critical but unfortunately often lacking component of decision making. So while we work most directly with people who manage forests, governments, local NGOs, companies, local communities, we also see educators as being able to benefit from this interactive tool just to enrich the sometimes abstract concepts that you're trying to teach about. So after giving you a quick tour of the website, I'm just going to talk a little bit about how Global Forest Watch can be incorporated into curricula in specific disciplines. Okay, so what's Global Forest Watch? Global Forest Watch is an online platform that leverages a convergence of technologies to gather, analyze, and share information about what's happening in forests to facilitate better forest management decisions. But in addition to it being a website, GFW is also a very unique partnership that brings together more than, we keep growing, so I think we're up to 60 partner organizations right now who are absolutely critical to the success of this project by contributing ideas, analysis, data, funding, and all of this comes together to empower a variety of users. So essentially, Global Forest Watch is a platform that funnels data collected at all different scales by all different kinds of people and organizations, from satellite imagery providers to national, regional, and local governments, to individual actors within the online community who can contribute data and thoughts through online crowdsourcing technology. Global Forest Watch then makes all of this complex data easy to understand, decision relevant, and in near real time to deliver information to the stakeholders who actually need it and want it, including governments, business, civil society, local communities, and like you. So in the specific context of higher education, Global Forest Watch can be used by educators like yourselves to demonstrate principles in the classroom that might be more abstract than you would like them to be, using the most updated, accurate data on forests. Students can also benefit from GFW by visualizing topics that you're teaching them, and just generally increase geoliteracy. The world does exist outside of Pennsylvania. The world does exist outside the US. So just the ability to teach geography in general. And researchers can also conduct analyses using open and accessible data. So I have some screenshots here. I was preparing for the talk with my webcam tonight, but we actually do have internet. I have to switch over to this one. So I'm just going to give you a little tour of the Global Forest Watch website right now. And the website itself hosts a map, country pages, stories, blog, data downloads. And so really at the heart of this whole thing is the interactive map powered by Google, where we can see a variety of different geospatial data layers that are all relevant to contemporary forest issues. So we have forest change data layers, both loss and gain in tree cover. We we also have near real-time alerts of forests that are being cleared. The alerts are monthly. So the first change products are on an annual basis, but then we also have these much more time frequent, coarser spatial resolution alert systems. We also have relevant data sets on tree cover extent, carbon stocks, intact forest landscape. I'm not going to go through all these. Forest use, there are a lot of ways that different people and different companies use forests. So some use them for logging, some mining concessions, oil palm land use, plantations to create wood fiber for pulp and paper. And all these different types of land use are using forests that result in some sort of observable change in imagery. So all these forest change products are derived from remote sensing imagery, such as Landsat imagery, MODIS imagery, at different spatial and temporal resolutions. Conservation layers, we also have some protected areas of protected areas, biodiversity hotspots, for people who are interested in local communities and who are like the social science side of teaching about climate change and the importance of forests to many communities in developing countries, resource rights, land rights. And so I think I'll just start off by doing a couple of examples of the beauty of this is its interactivity, right? So we'll start off with a place that we all probably know has a lot of deforestation, the Amazon basin in Brazil. And so we can look at Brazil and zoom in, and we have a little time slider starting from 2001, and we can see how much forest clearing has happened over just the last 10 or so years. This is the visualization of what we would never be able to translate to students using just tables of forest loss per country, right? The platform also, we have a default just geographic map, but we also have the satellite-based map that you can change, so you can really zoom in and see what's happening. If you click on this little analysis button, the one that looks like a graph, users can draw a specific polygon around whatever area they might be interested in and calculate how much forest change has occurred within that area. And you can also change the years, so if you're only interested in things after 2006, you can filter by year. You can also sign up for alerts. So the Forma alerts or Amazon alerts are more real-time alerts. So you can email yourself. So here's the area I'm interested in. Email me if something changes that I can then take action. So it's a pretty interactive and powerful way to show forest data. But suppose, I'm not interested in Brazil. I'm interested in the Keystone Pipeline issue. It's in the news right now. So we can go to Fort McMurray, which is in Alberta, Canada. You can zoom in here and also look and see what's going on as a result of all of that. We have losses here, or gains here in blue and losses here in red. So if you do the same time series presentation, you can see that there's a lot of forest loss happening because of all of the activities that are currently occurring. We don't really think of deforestation as being a really US issue, because most of the forest extent in the US is pretty well managed for timber plantations. So if you zoom out and we look at the US in general, the southeast US has a lot of forests, right? And you can see a combination of red and pink and blue. That represents the kind of rotation cycles of US forestry. So that there are some areas that are regrowing forest, there are some areas that are clearing forest, but across the entire landscape, forests are well managed. But that's not necessarily true in all of the US. So for example, suburbanization is really a problem in some areas. Just another example of Ackworth, Georgia, which has a lot of forests, and we have some blue here, but if we do the time series, we also see a lot of pink. And all of that pink loss is due to fact that people just want more and bigger houses, they want golf courses. So it's not just a tropical problem. This is forest loss is a global problem, and it ultimately contributes to the problem of climate change. So the interactive map is a good way. Just think of it as just this giant research report that's fun to play with. We don't know what questions are interesting to you. I just showed you a couple of examples, but the beauty of this is that you can look at wherever you're interested in and do your own analysis, make the data yours in the way that you want. We also have country pages where all of this information is compiled both at the country level and the state level. So if I'm interested in the United States, we can select at the country or the state level for any country in the world. And we can see, for example, how many jobs come from forests, or how forests contributed to emissions or GDP. So you can see the data on the map, you can follow it through time, you can download it, adjust it to your scopes and your terms. Downloading data, all the data on the GFW platform is open and available for download. So if you see something interesting that piques your interest and you want to do further analysis on the data, all of the spatial data that you see on that map is available to work on offline. We also, on the map page, we also have user stories that people can submit about forests. So, for example, if one of your students is really into a forest issue and they find something interesting to say about it, they can upload a story onto the Global Forest Watch platform so that other people can kind of learn and share information. So that is the main platform. In addition to giving you that quick introduction, I also wanted to try to think about how Global Forest Watch could be used to teach about specific disciplines and incorporating climate change into specific disciplines that you are all teaching about. I know there's a lot of biology professors here, geography, but I also noticed some not non-traditional, but not hard science, right? We have economics, we have business, people from the business school, we have English departments. And so first, I'm going to switch back to my PowerPoint here. The first example of a discipline that might be sort of difficult to really get the concept of climate change into is the world of business and economics. So we're, in addition to the main platform, we're also working on a suite of applications, or apps we're calling them, that present GFW through a very focused, targeted user group lens. So the first app is GFW Commodities. So we're trying to target company commodity supply chains. And why was this the first app that we started with? Well, a major driver of deforestation worldwide is the expansion of all of these commodities to feed and fuel a growing population, right? So we have commodities like palm oil, timber, soy, beef, pulp and paper, biofuels. All of those crops need to be grown somewhere. And as a result, forest clearing results. And what we started with was palm oil, because palm oil, it's estimated that palm oil is in almost over half of all the packaged food that you find in the supermarket. It's cheap. Countries like Indonesia have responded. Palm oil is Indonesia's biggest export, and palm oil production has increased over 400% just in the last 20 years. So this is a rapidly growing commodity that's found in anything but from ice cream to soap to lipstick to donuts, you name it, palm oil's in it. The problem, here's just some pictures of what the effects of growing these commodities is on the landscape. So some of these areas are just massive in size, 10 or 20 kilometers across. And the province of Riau in Indonesia is one of the fastest, has one of the fastest deforestation rates in the world. Just to put a picture to the word, this is palm oil crop that's harvested in fresh fruit bunches that are then trucked off to mills and refined into oil. Unfortunately, palm oil plantations require severe changes to the landscape. Land use change emits all the biomass that was cleared to plant that crop. A lot of areas in Indonesia also have highly organic peat soils that have to be drained first before the palm oil crop can grow. And all of the organic carbon in that peat is emitted into the atmosphere when they drain it and burn it. And so consumers and campaign organizations have shown the spotlight in recent years on companies who are sourcing palm oil from tropical rainforest regions such as Indonesia. And companies are responding to these pressures by committing to zero net deforestation policies, enhancing traceability in their supply chains, and changing the suppliers that they buy from. So recently, a company called Unilever, they make everything from Ben & Jerry's to Dove soap. They pledged to use GFW commodities as a tool to ensure zero net deforestation within their supply chains. So many commodity producers, traders, consumer goods manufacturers have come on board with commitments to this zero deforestation commodities policy. This chart just represents the companies that are committed to palm oil, but the producers and traders represented here represent more than 60% of all the trade in palm oil. So it's a growing phenomenon. The New York Declaration on Forests that occurred last September as part of the UN Climate Summit brought even more to the table. Now we're seeing many of these commitments extending beyond the palm oil sector. So there's a movement here. I'm going to switch back to the website here. So this is the commodities website. It looks very similar to the main platform, but the data that we have here is specific to commodity production in Southeast Asia for palm oil specifically. So if we can turn on different layers just like we did before. Let's turn on the loss layer. Just a ton of forest loss happening in Indonesia that you can see happening through time. Slowly but surely. We have, on this commodity site, we have more than just palm oil. We have wood fiber and paper pulp plantations. We're also moving this year into beef and soy. So we had to start somewhere.
The red indicates loss. It's not forest cover, it's just loss.
So forest cover, let's see. That's forest cover. All that stuff that used to be green in 2000 is now pink in 2012. So we can turn on concession areas where palm oil is grown, and we can do analysis. This is where the companies come in. They can do an analysis of the areas that they source from. On oil palm, and we have all the company information from various oil palm suppliers in Southeast Asia. So for example, you could use Global Forest Watch commodities to have your students look up the companies that are the good actors versus the bad actors in terms of this zero deforestation policy through time. So that's Global Forest Watch commodities. We switch back over. Another one is political science. Might be a little bit hard to talk about climate change in a political science lens or law lens. And one other application that we're working on now, or have over the summer, is Global Forest Watch fires. So fires aren't really a natural occurrence in a lot of the forests of the tropics, but for example, in Indonesia, when people clear forests for oil palm, they'll just set fire to clear the land quickly. It's a lot cheaper and a lot faster than other mechanical ways of clearing. And so those fires have contributed to a lot of haze in Singapore a couple of years ago. So it's a real problem. It popped up in the news all over the place. Singapore's air quality was really bad. It was affecting, schools were closing, businesses were closing. It had major economic impacts. So it resulted in sort of an international diplomatic crisis. The president of Indonesia issued an official apology to Singapore for basically causing such bad air quality in Singapore because of the fires that were occurring in that Riau province due to oil palm conversion. So haze caused by burning peat forests in Southeast Asia kills an average of 110,000 people a year and up to 300,000 during El Niño events. So global forest watch fires is just something that we didn't necessarily plan on doing, but it just seems too easy not to. We produced a series of blog posts over the summer using simple GIS analysis and publicly available data that revealed some important patterns about the fires. Most fires are concentrated in a really limited geographic area. Because we had all of the information about who owned all of those different boundaries, we could identify which companies held land holdings with the most fire alerts, so we could name and shame these companies into doing something about it. And despite the fact that all this information was publicly available, none of it had been presented like this in a way that was helpful for decision makers. So as a result, the Singapore Transboundary Haze Pollution Act was passed last fall, I think it was August or September or something, where the Singapore government can basically prosecute and fine companies responsible for fires causing pollution in Singapore, regardless of which country the company is currently operating in. They could be operating in Singapore or Indonesia or the US, but if they could eventually be traced back to the source of the problem, the Singapore government can fine them. The law was first proposed after that big outbreak in 2013. It was just passed last August. So this really sends a powerful message to those who burn and clear lands illegally. All the fire stuff is technically illegal, right? But everybody does it. Because they don't get caught, it's really hard to prove things. So it also brings up questions about evidence, using remote sensing imagery as evidence in courts of law. We have this partnership with Digital Globe, which is a really high-resolution satellite company that collects imagery at, I think it's 30-centimeter resolution. It's basically taking pictures from space. That's the level of detail. So during this project, we use NASA active fire alerts that are just pretty coarse hotspots of where fires are currently occurring. And we use those to task this high-resolution satellite on the areas that we know from coarser resolution of burning. And we can identify very precisely, we can distinguish between healthy and dead vegetation, we can draw burn area boundaries, we can detect burn scars, and pinpoint precisely on the landscape where that's all happening to determine responsibility for the fires and better understand the long-term trends. So you can see in the imagery, even the flames of active fires can be clearly seen together with their smoke plumes. And Digital Globe also has this crowdsourcing platform called TomNod, which kind of came into the public eye when the Malaysian Airlines flight went down last year sometime, where everybody was using this crowdsourcing to look through imagery to find the plane. Well, we also have a Global Forest Watch crowdsourcing function in this TomNod, where you can look, anybody, students in Indonesia, students in Pennsylvania can look through imagery and tag fires that they're seeing, because we obviously can't go through everything. So the online community can help to identify what's happening. So I just wanted to leave a little bit of time for questions. So I just want to summarize by talking about how Global Forest Watch can be used in your classrooms to teach about climate change. So obviously, GFW is a very powerful research tool, teaching tool. Interactive visualization really helps to get points across that are tougher to get across using more abstract methods. But creative writing, you can have students talk about write stories about forests and submit them to Global Forest Watch. We're also continually in the process of refining our website to make it more usable for people who don't look at this website all the time. So you can have your students sign up to be a GFW tester. That would be awesome for us. We also have a second round of small grants funds program that we're launching now. The small grants funds are somewhere between $10,000 and $40,000 issued to nonprofit, civil society, academic organizations that are using Global Forest Watch to improve forest management at the local level. So projects can use Global Forest Watch as a means to communicate with grassroots communities, to advocate for improved forest management, to create new information that we don't have on the platform. There's a lot of information we just don't have yet. Or to validate existing information. All of those products have sources of uncertainty that we're trying to grapple with how to reconcile differences. And just other myriad ways that you guys can think of to help civil society better manage forests and sustain livelihoods of people. That's all I have. I can take some questions. If there's time left over, if nobody has questions, I can show you the fireside. I didn't know how long this is going to take, so yeah.
Hi, I was wondering if you already had some pre-made student exercises there. I mean, I could go through and spend a lot of time searching for something and coming up with an exercise, but what would make it easier for me to use is you know that database better than I do, and what's interesting and what's valuable to students. So just as a thought, if there were already pre-made student exercises there, I think it would make it a lot easier for faculty to incorporate them into the courses.
You're reading your mind, because we're in the process right now of creating these teaching modules or research modules exactly for this purpose.
Excellent.
How do I field? We'll take it some from this side, some from this side.
I understand the use of Google as your platform for the interactive map on the web. Is the geographic data downloadable in formats other than Google files?
Yep. So on the main site, on the data page, all the data is available on Google Earth Engine, but is also available on ArcGIS Online, and you can also just download the raw shape files or whatever. Download a variety of different formats. Susquehanna.
So for those who aren't going to download the data to put into a GIS, are you on the online map? Can you do overlays such as like if hotspots and forest cover change? Are you able to do some overlays? Some simple things?
Yeah, so if we first, Uganda, it's a big place with biodiversity conservation, lots of charismatic species roaming around. You can look at biodiversity hotspots and look at how much forest loss is happening within there or within protected areas. For example, if you wanted to zoom in and click on this protected area, you can also do the pre-canned analysis here. Click the analysis button and it would tell you how much forest loss and thinking is happening within the specific area. So yes, but in terms of the overlays that we don't have on here, we're working on a feature where you can upload your own shapefile. You can do that on the commodities site right now, but you can't do it on the main site. You can upload your own shapefile and do your custom analysis online. Because I think that's a hindrance for a lot of people who don't necessarily know GIS. They don't know this GIS software, but they want that information. And so we're trying to make it more easy for people who don't have GIS background to do analysis.
I suggest in response to the first question that you might also want to crowdsource some assignments for this, and you could contribute those online, and you could get a huge repository of assignments. My question is, does this
because we work with Google, we have all of the Google features. So we have GFW. What language do you want? There we go.
So here's how it might be used in the English classroom. I would be interested in seeing the difference between the rhetoric that's used to describe certain narratives experiencing forest loss. For instance, the difference between the way an indigenous person from Malaysia might describe forest loss versus the way a public relations flag from Cargill might explain forest loss. And I can compare those two versions of this same story and think about the difference between power relationships, access to knowledge, a whole variety of other things that would be relevant to the human story of this process.
Yeah, at the most fundamental level, we run into issues about people's differing perception of what is a forest even. A forest to a local indigenous community could be a completely different definition than how we're defining forest from satellite imagery, right? And so some of the problem in this discrepancies among all these different data sets is we're talking about different things here.
Two things. You could also do something where you compare now, let's say, the world of Peter Matheson in English class. When you have mining there, does that include oil and gas development? Or how is that disaggregated or separated?
The use data is a tricky one because it's all about, getting that data is all about forming relationships with all the people that we need to get the data from. And those relationships take a while to form, and the data that they have might include certain things but not other things. To try to make a mining consistent data set is challenging. And so if you look at the data sources, maybe just switch back to English for my own benefit. If you look at the forest use concession or land holding, it'll say source data. It's kind of whatever we can smush together from the best available data that we have.
So if I wanted to use this source in a class to try to like disaggregate shale gas development and pipeline development in state forests in Pennsylvania.
Shoot, I was going to do a Pennsylvania example.
Right. What am I going to find?
So there's a lot of mining out by State College up here. Is that right? I was looking online to see.
Sure.
So we don't have data. This is an example of stuff. We know there are mining activities. We just don't have the boundaries of what's happening. But if you press the play button, you can definitely see that there's forest loss happening in areas.
And you go back like 5 years and it starts.
Yeah.
So.
And even my sister, Dr. Straub and I were looking around Sealands Grove last night. And you can see areas east of here. There's University Ave, that's where we are. And over here, we switch over to the satellite view. There's a lot of mining happening around here too. Go back in time to the beginning of the decade and see what's happening in terms of forest loss due to presumed mining activity.
I'd be interested, I'm an anthropologist. I would be interested in some functionality where you could see which indigenous communities were living in these areas, and then you get an ethnography about them, you can see in real time what's happening to their environment.
And our people here, we
have that?
Yeah, we have indigenous rights. I know we have them for Brazil. They're sort of a vocal group of indigenous people. So we have the boundaries of
appreciated your opening comments about the importance of the plants and their role. I mean, that's kind of like the understanding that needs to be in place for this to have meaning, and I find that very hard. And I think you were exactly right about the concentrations on emissions, you know, in our public conversations, mostly about emissions. So I wondered if you addressed that anywhere on your website about the role of forest and how the relationship with climate change.
So I presented commodities and fires as our first two apps. We're now developing a GFW climate app that's going to be very specifically focused on the role of forests and contributing to climate change. So maps of biomass, maps of carbon fluxes coming from the atmosphere that will get more clearly at that question. I started working on this project in mid-summer of last year. I got there and I'm like, but we don't, where's the climate change part? That's kind of the big part. So that's my personal crusade.
Let's just take maybe one more question, and then we'll need to move on to the next sessions. And Nancy will be here through lunch, and I think through Kirsten's talk this afternoon. So if you want to talk to her at lunch, or she'll be able to answer questions. So maybe let's just take one more question.
Have you thought about, or has the project thought about how to deal with lying or cheating or false data? Or have you, given the political value of this kinds of claims, and the commercial value of these kinds of claims, how do you
We think about that all the time. And not necessarily, we can't necessarily do anything about it, but communicating it is really important. Communicating the quality of different data sets, like the oil palm boundaries in Indonesia. We know those aren't great, but it's the official government data that we can get, and we just have to live with it. How do we communicate that information to the people who are using it and using it as truth, right? So we've started talking about doing some kind of summary overview of data quality assessment or something. That it's tough because you're talking about so many different sources of data. That how do you develop one quality index? But we're thinking about it.
All right, well, let's thank our